direction, right? If moment is in the Z direction, you have to use what? IZZ, okay, multiplied by Y, okay? So it is different. So now the thing is this, okay? What is this IZZ? So in order to calculate IZZ, right? In order to calculate IZZ, so this is equal to N, okay? So that's a coefficient width times depth cube. Okay, so these two are one term. The other two are, they're divided by 12, right? As I said, the D is based on your original depth. Okay, that's why we did not change at all. Whereas the width is changing, okay? Then plus by NW. So this is the one that's changing to get the equivalent material multiplied by depth. Okay, so over here, this is our area. Okay, and the fact that we did not change the what? We did not change the depth. That's why we can have y bar minus y bar squared. Okay. So for this case, I'm going to show you, okay, how to determine the second moment of area. Okay, it is also as important. Okay. So now we know that the N of aluminum is equal to Young's modulus of aluminum divided by Young's modulus of aluminum. So this is equal to 1. Okay. And then the N of Kevlar is equal to Young's modulus of Kevlar divided by Young's modulus of aluminum. So this will be equal to 19 times 10 to the power 3, right? Divided by 10.6 times 10 to the power 3. So you can write this out as 95. Okay, use your calculator, you can get this value. 95 over what? 53. Okay, so 19 divided by 10.6 power 3. And you just press your calculator, inverse the fraction key. Okay, you get 95 over 53. Okay. So I'm going to sketch. Okay, I'm going to sketch how the structure look like first. Okay. So I'm going to sketch the original composite material geometry. Okay, you don't need to do this. I'm doing this so that you can visualize. Okay, you don't need to do this. So I say I'm doing this so that you can visualize. Okay, so in your exam or term test, you don't need to do this. Okay, so now what we want to find is IZZ. Okay, so I'm going to draw our transformation first. Okay, so this is our transformation. So this is your Y. This is your Z. Rotation about your X. Okay, so the original material, it looks like this. Okay, I'm going to sketch this. So 6. Okay, so this is your original structure, and then you have 0.5. Okay, bear with me. Sorry about this. I should have done this earlier. Okay, then you have another one coming across. Okay, so this is your structure now. So what we know is this is your, over here, the top piece. This is your aluminum. Over here, this is your Kevlar. Kevlar. Okay, so now we decided to put our reference material. Okay, we decided to use our reference material as aluminum. Okay, so reference material now right? So what this means is the aluminum did not change in size at all. Okay, you guys already know that the aluminum did not change in size at all. Okay, so the aluminum is the same. Oi, move. Oi. Yep. So aluminum did not change in size at all. So you can see down here, the aluminum is changed. It did not change in size. Okay. However, now the Kevlar, right, is like 95.73. So 95 over 53 is 1.792. Okay. So that's the coefficient. So again, the thickness did not, the depth did not change. Only the what? The width changes. So I'm going to sketch this out. So now our thickness changes. Okay, so I'm going to eyeball this. Okay, but I want you to watch this. Okay, so the depth is 3 squares, right? So the depth did not change. So I'm going to approximate is over here, right? The depth did not change, right? So now this piece will go here, right? So the width changes, right? The width changes, but the depth did not change. Okay, the depth did not change. So the width changes, right? The depth did not change. So this is what is going on. Okay, so this is how we're analyzing the structure now. The width changes, the depth did not change, right? So now this is the top. Now everything is aluminum. Okay, so now this is aluminum, and on bottom here, this is also your aluminum. Now everything is aluminum to you now. Okay. Okay. So now the first thing that we're going to do now is like before, we now have to find the centroid, because now we have not a clue where the centroid is. Okay, so I'm going to label this 1. Okay, 1. This section 1. Then I'm going to divide this. Okay, let me see. I'm going to 112. I'm going to divide this into. I'm looking at my geometry now. I'm going to divide this way. Okay, so this is my number 2. This is my number 3. And this is my number 4. Okay, and we know 2, 3, and 4 are all Kevlar. Okay, so now we are good. The first thing we are going to do now is we're going to find centroid, right? We'll find centroid. All right. So centroid. So we have section. So for this case, you have to add something extra. Okay, so to make you less confused. So section 1, 2, 3.
Eugene, can I have a question?
Yes.
Does the width of 2 and 3 change too?
Yes.
Okay.
Okay, that's why I draw it slightly thicker. Okay, slightly you can, yeah, the width of 2 and 3 did change. Okay, and then you have material. Right, so it's good practice to do this. I know some of you in your term test you did not do this, and then you make mistake by accident. Okay, I think it's good practice that you hopefully could follow this, then you make less mistake. Okay, so material for 1 is aluminum. 3, 2, 3, and 4 are of Kevlar. And then the next thing, what I usually do, I usually put the N value. Right, so this is 1 because the reference material is aluminum, then it's 95 over 53. Okay, and then after that, you calculate your N, width, and depth. Okay, so over here, so we look at our N is 1. For the aluminum, the top part, the width is 12. The depth is 0.5. Okay, so this is equal to 6. And then for number 2, right? So number 2 is over there. So N is 95 over 53. The width is equal to 0.5. And then the depth is equal to 6. Okay, the depth is equal to 6. Okay, so this will be equal to 95 to 3 times 0.5 times 6 is equal to 285 over 53. So 2 and 3 are the same. Okay, 285 over 53. And then the bottom one, so 95 over 53. The width now is what? So you look at the width is 12 minus by 1 equal 11. Wait, is it 12? No, it's still 12. Yeah, it's 12. It's not, yeah, I don't need to minus by 0.5. So the width, wait, the width is equal to, yeah, the way I've divided it, the width is 12, right? And then the depth is 0.5. So 95 over 53 times 12 multiplied 0.5 is equal to 570 over 53. Okay, so 12.5, 0.5 times 6, right? Okay, so the next one is my Y bar, right? It's our small Y bar. So for this case, I'm going to take the datum from the top. Yeah, I'm going to take the datum from the top. It's moving downwards. So later when we find our centroid is from the top. Okay, so this one is equal to 0.5 divided by 2. So 0.5 is 0.25, right? And then the 2 and 3 are the same. It's 6 divided by 2, right? So 6 divided by 2 is equal to 3. This is also equal to 3. And then the last one is the entire height is what? 6, right? 6 minus by 0.5 divided by 2. Okay, so 6 is 5.75. Okay, then we multiply everything together. So you have N so 6 multiplied by 2.5 is equal to 1.5. 3 times by 285 over 53 is equal to 855 over 53. 855 over 53. Let me check. Yep, 285 over 53. 855, yep. So 570 over 53 multiplied 0.75 is equal to 6555 over 106. Okay, then you do the sum. So 6 plus by 285 over 53 plus by 285 over 53 plus by 570 over 53 is equal to 1458 over 53. And then it's 1.5 plus 855 over 53 plus 855 over 53 plus by 6555 over 106